All right, so thanks for inviting us to give this talk. I'm Myra Lattimore, and as was mentioned, I'm a software systems engineer at NASA's Jet Propulsion Laboratory. And today I'll be presenting alongside Lucas from Boeing about how OpenMBE enables the adoption of a model-based digital ecosystem at Boeing and JPL. So today's presentation is divided into about 3 sections. We'll start with an overview of OpenMBE and kind of discuss the story of how it came to be. And then Lucas and I will talk about how OpenMBE has been used at our organizations. And then hopefully we'll have some time for a few questions at the end. So OpenMBE is a community centered around open source models and modeling software. And it was established out of the need for many organizations to create model-based engineering environments to deal with the challenges of building complex systems, and really serving as an enabler for us to transition towards a model-based systems engineering paradigm. So OpenMBE provides a number of apps and services that we can use to manage models, and close the gap between models and engineering artifacts like documents. The core software began as core software released from JPL, but since then it's really grown to include a larger community, which includes more than 400 adopters and contributors from across industry and academia. So we can see a few of the organizations that are active participants in the OpenMBE community. So what does an OpenMBE do, and what problems does it solve for us? To answer that, let's talk about engineering documents. So supporting systems engineers is really the key focus of OpenMBE. And today, systems engineers are building highly complex systems, and there's ever more collaboration associated with building these complex systems. And so systems engineers are particularly affected by this because they're very interdisciplinary in nature. So they are tasked with ensuring that the engineering disciplines come together and to produce a system that meets the requirements. So overall, we can say that systems engineers really guide the concurrent collaborative design of complex technical systems. And this is really a difficult thing to do. It's difficult, but nonetheless, we need to do it. So we need our systems engineers to be able to provide leadership through effective communication about their technical data. We need systems engineers who can architect and design these complex cyber-physical systems. And most importantly, we need systems engineers who can manage the complexity of the systems that we are designing today. So systems engineers need to bring all these things together, and even on large teams. The picture that we have here is just a portion of the Mars 2020 Perseverance rover team. And it's no surprise that it takes a lot of people to build a Mars rover. And back in the day, before we had more access to digital technology, document systems were used to do the systems engineering. So when there was a change to the system design, an engineer would issue a memo. That memo would be physically sent to someone who took the memos, reviewed the existing documentation, determined the impact of the change described in that memo, and then published a new document and provided a physical copy to all the engineers involved. So this process for doing systems engineering, keeping track of the current design and the changes, was used to actually design the Cassini spacecraft, which went and successfully explored Saturn for many years. So back in the days of Cassini, the cost of creating information was very expensive. So anytime somebody on the team wanted to make a change or create some sort of piece of information, they had to go through that entire memo process. And there was an entire team of people whose job it was to make sure that that information was correct and consistent. But these days, when we're designing systems like the Mars 2020 rover, and we have a team as large as this, because of the digital age, creating information is quite cheap. It's cheap and easy to circulate an Excel spreadsheet, a Word document, or a slide deck with lots of rich technical information. But we no longer really have that group of people that spends all day ensuring that every engineer has the same copy of information. And with the low cost of creating this information, everybody's doing it left and right. And so ensuring that every engineer has the most up-to-date copy is actually perhaps even harder than it used to be. And so what we find, we see it all the time at JPL, and I'm sure other organizations do as well, that a project starts simple. A few people make some models, create some technical documents, and those people iterate on those models and documents, and then more people are added to the team, more artifacts are made. The project continues to progress through its stages, so the information itself becomes more complicated, it continues to grow, and before you know it, there is an overwhelming number of people mixed with an overwhelming number of sources of information. And perhaps you are this individual in the center that is stuck in the middle of it and can't figure out what is going on, and you're struggling to find and locate the updated information. So this leaves systems engineers feeling like they really aren't doing meaningful work. An example here stating that most of my job is data entry. I want to do real engineering. And it's true that engineers have technical skills that we want to apply. So really using engineers as information janitors isn't the best use of their skill. So ideally, what we would like to do is have less overhead and spend more time doing real engineering work. So we want to spend less time doing repetitive data entry, spend less time figuring out which version is current, and spend less time searching for the information that our systems engineers need. So what's the better way? We have this mess of models and documentation and other artifacts of various versions and completeness, but we can reduce the clutter with direct data syncing. So for example, if we have the right software to if we have some models that kind of are collaboratively developed in a version controlled way, and we generate the documentation from these models, and then we generate and connect it to the other artifacts that we create, things are a lot more manageable. Understanding how everything is connected is a little bit more clear than over here on the left. So when we have the right software to maintain these relationships, our artifacts become connected and it's easier to search and navigate through. And this really is the main concept behind OpenMBE. So we really want to shift away from the manual and disjoint data management and towards a single authoritative source where we have connected information with and between our engineering documents. And we can see with this connectivity, it's a little bit easier to understand the impact that changes have on other artifacts. So if I make a change in my model, how does that propagate into my document and other artifacts that I've produced? So this is essentially the digital approach to the memos process that was used on missions like Cassini. And I think it definitely should be noted here that this transformation, while enabled by better software, is also cultural. So we all know that engineers, myself included, are still compelled to email spreadsheets around. So it takes some effort to shift to this single authoritative source. But if we're successful, we really can bridge the gap between the engineering work and the additional artifacts and documents that we also need to create as part of our systems engineering deliverables. And OpenMBE is really helping us do just this. So from the user perspective, OpenMBE allows us to update once and use everywhere. So if we have an individual who is working on their model of a spacecraft, maybe a SysML model, for example, and we have another individual who is working on a document description about the spacecraft, maybe as something they have to deliver as a gate product. We don't have to worry about data inconsistency between our users, because if we're using something like OpenMBE, we have a way to ensure that everyone is referencing the same information. So the software handles the synchronization of the data, and a user may not even realize that when an update comes their way, the engineer that made that update was working in a different tool. So if a change is made in the model, if we've generated the documentation from that model, the changes that the modeler made are in the document. And if our document is linked to the model, any of the changes that our document writer made also end up back in the model as well. So our data stays consistent. So these are the components of OpenMBE. I think it's important to note here that OpenMBE is not just the software platform, but also includes the documentation and examples of how the environment can be used. So OpenMBE has the model management system, which is the core repository that manages the federation of references. It has view editor and platform for model analysis, which is the document-based interface with its companion that's based on Jenkins that allows you to run executions that update your document. And it includes model development kits, which are how we integrate various commercial and open source engineering tools with the other components of OpenMBE. There are several model development kits. One of the more popular ones is the Magic Draw or Cameo Systems Modeler model development kit, but there are several others as well. If you explore the OpenMBE website, you also see some of the other ones that we have. And additionally, you'll also find documentation and training on how to use an OpenMBE, as well as the 30-meter telescope model, which serves as an open source example. And lastly, OpenMBE includes the OpenSE cookbook, which is a collection of modeling best practices and examples. So as an open source community, OpenMBE, again, is not just about the software platform, but also about providing engineers with the information, the example models, and libraries to help get them started using OpenMBE. So this is an example of OpenMBE in action. So in this example, we have a system model, for example, a system model of the 30-meter telescope. And we use a model development kit to sync that model with MMS, so the model management system. And from there, we're able to generate a document and publish it with View Editor. So users can edit the document and produce a deliverable like the OpenSE cookbook. So we see that the model management system really acts as a gateway for the single authoritative source of information. We also see that the model development kits support the integration with different types of engineering models. In this case, we had a model for the 30-meter telescope. And we also see that the view editor is really there for the consumption of those models. So engineers can look at these models using a traditional document format that engineers might be quite used to seeing. So it doesn't necessarily require them to be experts in understanding the model itself, but gives them a way to see a published version of information in the model. So altogether, these components produce a full functioning environment for doing engineering modeling. Another example that we can demonstrate is in the context of master equipment list, where again, we have MMS as the authoritative source of information. We have a flight systems engineer that wants to analyze the master equipment list, and a subject matter expert who wants to create a report of the master equipment list. So in this particular example, both people can work on the same data that is managed in the model management system, so that the data stays mutually consistent between the two sources. So we actually have a video demoing this. I think in the interest of time today, I'll pass since it adds several extra minutes to the presentation length. But I believe the slides will be distributed and this video is available on YouTube. So you're more than welcome to try it out and take a look on your own time. So as we said before, OpenMBE has really grown into a rich community of adapters and contributors across various disciplines. We've used it at a variety of projects at NASA, as well as other science and engineering projects, with the TMT model being of particular interest, since the model was used to generate completely model-driven documents. Industry has adopted OpenMBE, particularly Boeing, which we'll hear a little bit more about in the next section. OpenMBE has been a part of several standards, including the used in developing the SysML v2 standard. And most importantly, probably the most important thing about this slide is that commercial vendors have adopted OpenMBE. And this is significant because they have built integrations with their specific tools, so contributed to those model development kits, and provided users with the capability to use commercially provided tools along with OpenMBE. So in terms of scalability, the first big project that we at JPL used OpenMBE for was Europa Clipper, where there were 100 concurrent users with over 230 documents and decision gate deliverables produced, including 445,000 connections between elements. So the number of connections is really quite important, because historically, in a more document-based approach, these connections have been pretty implicit. So it's unclear as to where they exist. But now information can be more explicitly connected, and in a sense, this number of connections serves as a representation of the complexity of the system we've modeled. So on Clipper, the positive impact was really the reduction of overhead. In one particular case, they were able to produce an engineering document in about 4 hours, even though it would typically take over a week to produce that same document without OpenMBE. So the benefits of using OpenMBE were quickly realized on the project. Another mission that's utilized OpenMBE, the Mars 2020 Perseverance rover project, where there have been about 50 concurrent users, over 90 documents and decision gate deliverables produced, including 180,000 connections between elements. So the positive impact for the Mars 2020 team has been a deeper level of technical rigor. So the team completed detailed modeling and communication between systems and subsystems. And so they were capable of high fidelity connection tracking, like understanding which artifacts are connected. So the tracking of deliverables was one of the key accomplishments of the project and was enabled by OpenMBE. And we'll hear more about this in the next section, but Boeing has utilized OpenMBE at the enterprise level with over 1,000 concurrent users across 50 programs, and Lockheed has adopted OpenMBE as well with 100 concurrent users across 50 projects. So we've seen with these examples that there are a lot of users that have adopted OpenMBE within their organization. But the vision that we have is that we can take things beyond being within an organization and really make it inter-organizational. So being able to connect with OpenMBE directly between organizations. And this is the example that we're hoping to execute with the Mars sample return mission, where users will be able to connect different OpenMBE deployments and have access to all the information that is being used for different parts of the mission. And hopefully one day we'll be able to connect across essentially an entire fabric of models in cross-references. When Robert Carbon, one of the leaders of OpenMBE, talks about this, he typically references his time at CERN in 1990 when the very first web server went online. And he compares that experience to now when he's hoping that he's experiencing the first global engineering system coming online. So I guess that's a taste of the vision that we would hope to achieve with OpenMBE. So at this time, I'm going to pass it to Lucas, who will present about how OpenMBE has been adopted at Boeing.
Yeah, thanks, Myra. I'm Lucas Aviles. I'm on Boeing's second century MBSE team, where we deploy a whole model-based systems engineering tool suite to the entire enterprise, including OpenMBEE. And I'm going to talk a little bit about that. Next slide. So here at Boeing, we have very large, very highly integrated systems, and we have correspondingly large, highly integrated models. This table here is something that would be typical of one of our commercial airplanes. You can see the numbers here are pretty impressive. 2,300 functions, 10,000 data flows, on the order of millions of individual data parameters being processed, model elements in the 50 million range, 10 gigabytes or more worth of data, and all of that's being touched by 1,000 modelers or more. And clearly, handling that much data is no small task, and we need to use something like OpenMBE in order to be able to keep this much data straight and not drown in it. Next slide. So in order to do that, we deploy our systems engineering toolset that includes OpenMBEE, so we can take advantage of all of that functionality that Myra just described. This is sort of just a flowchart of how we deploy it at an enterprise level. So we have one single enterprise environment that all of our users are on. We start in the upper left with the OpenMBE GitHub. It says JPL, but we're trying to be more inclusive. We pull that down. If there's major changes, major versions, we'll do some initial testing in like a VM sandbox. And then when we're ready to work on it, we'll move it to a dev environment. Once we're in the dev environment, that's where we will work with the OpenMBE code. We work on things that slot into OpenMBE or draw from the same the MMS repository that Myra was describing. And then we also just develop other things as other part of our systems, plugins for Cameo, things like that. We run on a scaled agile framework, so we have a large 3-month program increment split into sprints. And so each sprint we push to a test environment where we would do automated functional testing, your scalability. And once it's past that functional testing, that's where you can see that kind of feedback where we would contribute back to the open source community. And at the end of that increment, once we have tested everything and are ready to release to our internal customers, we push to a pre-prod environment where we do our final testing, system tests, user acceptance tests. And once that's complete, we push to prod on a release weekend kind of thing. And we have a disaster recovery environment that's parallel to that we do backups to in case things go wrong. Next slide. So with that process, we get a global deployment of a single large OpenMBE powered environment across our entire organization. So we have international users across the entire Boeing company. This map here is actually even a little bit out of date as well. You can see we've got our major locations in the United States. Those other dots are for Moscow and Russia and India. We also have users in Boeing Defense UK and the United Kingdom. We have Boeing Research and Technology in Europe, users across Europe, and also Boeing Defense Australia that aren't shown there. And for those far-flung locations, we take advantage of Citrix and virtualization to reduce latency and lag for some of those users. And all this, like I said, is one large deployment of OpenMBE. We use the Teamwork Cloud and the MMS access control system to partition the data. So we have a system set up where users request access to specific projects on the servers, and with permission from the model owners, they can get access. So we grant that approval by project. Next slide. And so with that global deployment, we have a common tool, a common modeling language, common training, and that one big environment across the enterprise. And that means that we can collaborate really easily across the entire company, and we can be really interchangeable across the entire company. When a user needs to help out another project, or projects need to collaborate with each other, or any number of connections across our entire organization, all of that's really easy because everyone is already in the same server setup. They already have the same software deployment, and it's just a matter of getting access to whatever projects people want to collaborate on. And then with that data lake of OpenMBE and the MMS server, we can use that source of truth to connect downstream engineering artifacts, things like using our systems architecture that we developed with OpenMBE to drive network and wiring design downstream in the electrical design space, connecting to our PLM systems to model-based design. And the other benefit of having that common IT infrastructure and single deployment is that for these individual programs, they don't have to worry about that anymore. In a lot of cases, there are times when a small group wants to start up a modeling project, do a small study, especially on our defense side. You have really small groups that just kind of spin up with maybe a dozen people. And in all of those cases, those users don't have to worry about where they're going to host their models, how they're going to, what machine they're going to have to get to run everything on. They just have to create that project in our enterprise environment, and they're off to the races and ready to go. Next slide. And along the way, we've learned some lessons. One thing that we've had trouble with in the past is migrations. When we have this much data being worked with, migrating between versions of server software is no small task. We've had nasty surprises on release weekends in the past. And so now we try to test these migrations as early as we can with as much real data as we can. We try to make sure that we contribute back to the whole open source community. That way, we don't go straight too far from what the rest of the community is doing, and we can take advantage of all of the great work that everyone else is doing as well. With that, enterprise deployment, we need to have enterprise level security. Obviously, with this much data being kept on these servers, we need to make sure that we're not exposing them in any way. And so we have to do comprehensive security scans on everything that we deploy before we can bring it out to users. And that's part of an enterprise security solution as well. I mentioned before the Citrix solution that can help with latency and configuration of software when you're working with a server that's halfway around the world. That can be difficult. And I talked about the restricted repositories and the way that we try to use Teamwork Cloud and MMS for access control. The other thing that I should mention is that we would obviously prefer it to be this way, but we are aware that one size does not fit all. We have cases where different customers might require different versions of software that is in our enterprise deployment, or cases where companies that we collaborate with or suppliers might have different deployments with different versions of software, or even in the defense side, we have classified programs that can't be connected to the internet at all. And so in all of these cases, we have to be flexible with our deployment and make sure that our enterprise system is flexible enough to be able to support those kind of use cases as well. And with that, I will pass it back to Myra, and she can talk about the deployment at JPL.
Yeah, thanks, Lucas. So in this section, I'll discuss in more detail how we have used OpenMBE at JPL to provide an integrated environment for systems engineering. So at JPL, I work in the CAE Systems Environment Team. It stands for Computer Aided Engineering Systems Environment Team. And really the goal of this team is to provide an end-to-end systems engineering environment for the engineers at JPL. So more specifically, we develop the capabilities of the systems engineering infrastructure and then tailor those environments to meet the specific needs of the flight projects. And from there, the flight projects can use these systems engineering environments to complete their tasks and produce deliverables. And really the idea with this environment is that we want these flight projects to have their models be connected to the artifacts that they produce. So a lot of engineers already use models, but oftentimes they are disconnected from other project deliverables. So they may take their model, but then copy and paste or do some sort of manual transfer of the information into the documentation, and then give that documentation to the person who is responsible for implementing it in code. And then test cases are created based on the code that was written. So in this example, the connections between the deliverables are weak at best, and in some cases non-existent. And there's a lot of opportunity for error. So when we provide the systems environment, the situation that we want to have is one where the models enable consistency across the transformed artifacts. So in this example, we would find ourselves generating the documentation and the code directly from the model, or performing analysis directly on model data. And when we do this, we have greater confidence in the correctness and consistency of our information. So with the systems environment, we enable the connection between artifacts by having a multi-paradigm modeling environment that is composed of a variety of apps and services. So rather than trying to use one single tool to rule them all, we really can take advantage of the benefits of each tool and bring them all together and work on creating integrations between the apps and services that we have. So we see here a few of the apps and services that are part of our systems environment. And the key concept here is that OpenMBE is really at the center of our systems environment. So Model Management System, or MMS, is one of the data repositories that we frequently use to store our models. And View Editor is one of the most popular ways for engineers on the flight projects to consume model information. And this is particularly the case for engineers who are less familiar with modeling languages. So would prefer to look at a document in a web app. We also have several model development kits in play. For example, the Magic Draw or Cameo Systems Modeler MDK is probably one of our most commonly used MDKs for connecting SysML models to MMS. But we have several others that we use. Another popular one is kind of just the Jupyter adapter to get your model data out of MMS and into Jupyter so that you can code with Python, for example. So really, OpenMBE is kind of the core of the systems environment. And we've kind of built on top of that to really bring value to the flight projects. So with this environment that heavily relies on OpenMBE, we have the ability to support an integrated pipeline for systems engineers at JPL. So they can use our systems environment to collaborate and capture information, to do requirements and system design, then to do an analysis, and then kind of publish the results of that. And because of OpenMBE, their data remains connected throughout this entire process. So last couple of slides here to talk about the goal for OpenMBE looking ahead really is to produce large-scale engineering ecosystems. We want this because engineering really isn't performed in isolation, but rather through collaboration with other groups. So two of the elements that are part of kind of our long-term strategy for a global engineering system are, first of all, Jupyter, which brings multi-language analysis capabilities. Essentially, we want to kind of marry the popularity of programming languages like Python with the rigor and durability of systems modeling. Other key enablers moving forward are SysML v2 and other standards. And lastly, we want to enable kind of novel data-driven analysis with advanced capabilities, but more importantly, like provide these as a service. So be able to do things with OpenMBE like graph querying or distributed computing or real-time collaboration, kind of like Google Docs. So for the last slide of this presentation, just a couple updates on OpenMBE. OpenMBE has a new home with NumFocus. And for those of you that don't know, NumFocus is an organization that kind of sponsors and promotes open source software. So OpenMBE is one of those, in addition to some other notable open source projects. And of recent, OpenMBE has been kind of getting a lot of attention and kind of gaining some popularity and has been discussed at some popular workshops such as Models 2020 and the INCOSE International Workshop. So it's definitely an exciting and engaging open source community to be a part of, and hoping that we'll continue to grow and produce great things for the systems engineering community. Any questions?
Yes, thanks a lot, Myra and Lucas, for the great presentations. Any questions from the audience? I'm sure there are. No? Otherwise, I have a couple of them. So the first question that I have is the following. So in order to manage the collaborative work among different stakeholders and different people working on the same project, essentially you decided for having an authoritative repository. So right, so all the people essentially connect to the authoritative repository, and this is the container of let's say the element that contains the model that represents everything about the project. So essentially a model that is a sum, let's say, of everything, because from that model you generate documentation, source code, all the different artifacts. Now, of course, this way of doing allows as a pro. The pros is that you avoid, you simplify the consistency management. because you don't have different views that are inconsistent, right? So essentially, by definition, the model is consistent. But as problem that you might have is that you reduce the reusability, I guess, of the model, right? Because you don't have modules that you could reuse. And also you might have also issues in searching for some parts of the model that you might reuse again for new projects. So can you comment on this?
Yeah, I think that's certainly a good point. To kind of build on that, we're using lots of different apps and services working on the same model data. So at times, yes, it can be kind of fairly confusing to kind of understand what changes are being made when you're looking at the model from one app or service versus the other. So I guess in terms of sort of breaking for reusability, we tend to kind of break the models into kind of separate models, but still stored within MMS, but still kind of chunked into smaller sections, so that there kind of is the opportunity for reusing those in your own project, since they're not all kind of packed into the same file. And then to kind of clear up the ambiguity that users may have for kind of understanding what changes have been made to the model from other apps or services. I think that really has kind of come down to organizing the views of the model. So particularly when we're generating the documentation, kind of having it be comprehensive, but also sort of organized and structured. Again, as I said, we really heavily use View Editor. So even if a modeler isn't necessarily interacting with the model in View Editor, they might be using some other app and service. I would kind of really rely on the documentation in View Editor to kind of provide that overview so that everyone can see what's going on in the models.
Yeah, and from the Boeing perspective, I could add, one of the ways that we try to account for reusability with our models is that we create model starter kits that are basically the structural framework of a particular project, the commercial airplane, a particular derivative, or a certain platform on the defense side. And then also, we also use the MMS to unite federated models. Our models bump up against what is possible from a scalability perspective, even just for the off-the-shelf tools like Cameo. And so one of the things that we do is we do split our models apart in MMS, but we build querying systems that can traverse the entire MMS repository and pull data from any of the models on that repository. And that lets us kind of get the benefit of that modularity and kind of get around some of those scalability concerns while still being able to view these models as one large connected source of truth.
Yeah, thank you. Yeah, this morning we had a presentation from Antonio about Hawk, that is a tool for indexing models. And since you are talking about huge models, so I'm guessing if you have any indexing mechanism for even supporting the queries that Lucas, you were talking about.
Thank you for the question, David. I was going to make it.
Yeah, okay. Yeah. So if you want to do it properly, please go ahead.
Yeah, so yeah, go ahead.
You can go ahead.
No, I was just going to reiterate the question from David in terms of the searching, because I was looking quickly at the manual for, say, the view editor, and I was wondering, how do you refer to SysML elements from inside a view and things like that? You must have some way of finding them or referring to them, I guess.
Mm-hmm. Yeah, so I guess there's a couple things here. To generate the views in View Editor, we're using the docgen query language. So really with that in our model, we kind of query and choose the elements that we expose to View Editor. And that's how we create the views with that kind of viewpoint method paradigm using docgen queries. One of the other things that we use for kind of indexing and querying models is inquiry. So we've been working more with using the inquiry platform for running fast queries on some of our larger models.
Thank you.
Thanks. Any other question?
I have a small question. This is Felicia.
Yes, please go ahead, Felicia.
I was looking at their website and they have that view editor. So I was asking, is it possible to reuse that, and do they provide the graphical editing, or is that the way of consuming the data?
Sorry, Felicia, the voice is very low.
It's very quiet.
The volume.
Okay. Let me see. Okay. Now can you hear me? Oh, it's very low. Let's see. Can you hear me now?
Yeah, maybe stay closer to the microphone.
Okay, I was referring to the view editor that they have. So is it possible to reuse that in case of diagram level? I mean, is it possible for a user to reuse that component of a view, or a developer to use that view editor component of OpenMBE, or is just tightly connected to the OpenMBE ecosystem in general?
Yeah, so View Editor is a component of OpenMBE. It kind of fits in with the model management system for kind of the repository for our models and references, and then View Editor for kind of interacting and creating documents and viewing the model data, and then those model development kits for connecting different apps and services to MMS and View Editor. So those are the three components. So yes, View Editor is part of OpenMBE. I didn't quite catch your question about the diagram part of it.
Yeah, I guess what Felician was asking, if it is possible to reuse the View Editor as a component in another project, so without using the other parts of OpenMBE. So if you, I guess, is it correct, Felician? This is what you wanted to ask?
Yeah.
So I think the answer for you is not quite. So not quite as a standalone. So the information that you see in View Editor is backed by MMS. So it's essentially taking those DocGen queries of the MMS data and publishing them to View Editor. So if you wanted to have like a completely different instance of View Editor that was populated with the same data, you would need to have it kind of backed by MMS as well to kind of hold the data that View Editor is showing. But since View Editor is a web app, that means that anyone can go to that URL that has access and see what you have in your View Editor page. And so I guess in terms of reusability, it's highly accessible. So other projects could look at the View Editor pages of other projects. And you can even export them as PDFs and Word documents and things like that. So View Editor is backed by MMS data, but it is fairly accessible by other groups once you've kind of got it, have it deployed.
Okay, thank you.
Thanks. I don't know, any other question? Otherwise, we thank the speakers. Any other question?
Just one very quick question, if
Yes.
I may. Yeah, thank you very much for your presentation. I was looking at the OpenMBE website, and I was wondering if the 30-meter telescope model is available, because I can see a link to the editor, but not to the actual model.
Yes, the model itself is available. I believe it should be on the GitHub page. So if you go on the website to the participate section and then follow the link to the GitHub page, it should be in one of the repositories on that GitHub page. And yes, there also is the View Editor link to it as well.
Okay, so what format is it in?
The model itself is probably in an MD zip format. So if you have access to Cameo Systems Modeler or Magic Draw, you
Right.
would be able to open it up
Okay.
in that tool. Yeah.
Okay, great. Thank you.
Okay, thanks a lot